Vacuum forming is a simplified version of thermoforming, whereby a sheet of plastic is heated to a forming temperature, stretched onto a single surface mold, and forced against the mold by a vacuum. The vacuum forming process can be used to make a wide variety of products such as product packaging, speaker casings and car dashboards. The first commercial manufacturer of vacuum-formed plastics was Robinson Industries of Coleman, Michigan. Process: vacuum forming is usually, although not always, restricted to forming plastic parts that are rather shallow in depth. Thin sheets are formed into rigid cavities for unit doses of pharmaceuticals and for loose objects that are carded or presented as point-of-purchase items. Thick sheet is formed into permanent objects such as turnpike signs and protective covers. Normally draft angles are present in the design of the mold to ease removal of the formed plastic part from the mold. Relatively deep parts can be formed if the formable sheet is mechanically or pneumatically stretched prior to bringing it into contact with the mold surface and applying vacuum. Suitable materials for use in vacuum forming are conventionally thermoplastics. The most common and easiest to use thermoplastic is high-impact polystyrene sheeting. This is molded around a wood, structural foam or cast or machined aluminium mold, and can form to almost any shape. Vacuum forming is also appropriate for transparent materials such as acrylic, which are widely used in applications for aerospace such as passenger cabin window canopies for military fixed-wing aircraft and compartments for rotary-wing aircraft. Vacuum forming is often used in low-level technology classes for an easy way to mold. Typical applications: original equipment manufacturers utilize heavy-gauge vacuum-formed components for production quantities in the range of 250 to 3,000 units per year. Vacuum-formed components can be used in place of complex fabricated sheet metal, fiberglass, or plastic injection molding. Typical industry examples include kiosks and automated teller machines, enclosures for medical imaging and diagnostic equipment such as magnetic resonance imaging machines, engine covers in a truck cab, and rail car interior trim and seat components. Common problems: there are some problems encountered in the vacuum forming process. Absorbed moisture can expand, forming bubbles within the plastic's inner layers. This significantly weakens the plastic. However, this can be solved by drying the plastic for an extended period at high but sub-melting temperature. Webs can form around the mold, which is due to overheating the plastic and so must be carefully monitored. Webbing can also occur when a mold is too large or parts of the mold are too close together. Finally, objects that are formed often stick to the mold, which is remedied by using a draft angle of 3 degrees or more in the mold. Types of molds: there are numerous patterns one can make with vacuum forming, it all depends on what you want to achieve. From the most obvious, such as wood, to more unique patterns, such as cylindrical or angled forms, many forms can be achieved. The most inventive way to use vacuum forming is to take any small item, replicate it many times and then vacuum for the new pattern to create a more cohesive form. The vacuum forming helps tie the individual pieces together and make one mold out of many pieces that can easily be replicated. From there, you can cast plaster, concrete, etc. into the plastic form. Wood patterns are a common material to vacuum form but probably the most obvious. Wood is relatively inexpensive and allows the customer to make changes to their design easily. Using recycled objects or forms are the most sustainable way to make a vacuum form because they are found objects at no additional cost. The number of samples that one is able to get from any pattern depends on the size of the part and the thickness of the material. Once the specifications of the part have been met, the pattern is then used to create a ceramic composite mold, or cast aluminum mold for regular production. Potentially, there are ways to create holes in plaster with a vacuum form if the replicated forms you make the vacuum form from are deep enough and you leave gaps between them for the plastic to form into. Then, once the plastic is used to cast a plaster mold, the deep plastic areas will leave holes if you don't completely fill the mold. Cast aluminium molds are cast at a foundry and typically have temperature control lines running through them. This helps to set the heat of the plastic being formed as well as speed up the fabrication process. Aluminium molds can be male or female in nature, and can also be used in pressure forming applications. The main drawback with this type of mold is cost. Machined aluminium molds are like cast aluminium, but are cut out of a solid block of aluminium using a CNC machine and a CAD program. Typically, machined aluminium is used for shallow draw parts out of thin gauge material. Applications may include packaging and trays. Cost is a significant factor with this type of tooling. Composite molds are a lower-cost alternative to cast or machined aluminium molds. Composite molds are typically made from filled resins that start as a liquid and harden with time. Depending on the application, composite molds can last a very long time and produce high-quality parts. Finishing methods. Once a vacuum forming has been created out of a sheet of plastic, a finishing operation will be needed in most cases to turn it into a usable product. Common vacuum forming finishing methods include guillotining. The product is cut out of the sheet by pressing a blade through the product into a die manufacturing, underneath. This is a clean way of removing vacuum-formed parts from the material sheet. It doesn't require a special cutting tool to be made for an individual product and is therefore suitable for low volumes of parts where straight lines are no problem. It can only cut straight lines and as it is a fairly slow method. Drilling. If simple round holes are the required finish, manually drilling them is a good solution for small quantities. Drilling guides can be used to ensure holes can be drilled quickly in the right place. As this is a labor-intensive method, it is only suitable for small production quantities. Roller cutting. Process whereby the vacuum-formed product is placed on a custom-made cutter and pushed through a roller cutter machine. An efficient way of cutting vacuum-formed items from the original sheet of vacuum-forming material. The cutter can also cut any necessary holes, such as cable or access holes, at the same time. Roller cutting is suitable for fairly large items, where precision alignment is not required. As the vacuum formings and the cutter are rolled sideways through the roller cutter machine, some misalignment can occur. Roller cutting can't be used for making holes or features in the sides of vacuum formings, as the cutter tool always cuts vertically from the bottom. Press cutting. This is a very precise method of cutting which uses a press and a custom precision-made cutting tool. This method is very suitable for items where the roller cutter process wouldn't achieve the precision required. It's often used for punching very small finished items out of a plastic sheet, rather than punching features into a product. Press cutting can't be used to make features in the sides of vacuum formings. Cutting with a CNC machine. Machining is a very precise method of creating holes and features. The real advantage is that it can be used to create features in the sides of vacuum formings, for example guide rails for a tray that needs to slide onto shelving. It can also cut side walls of a different depth than the pockets, which cannot be done with roller or press cutting. See also, Vacuform, a toy from the 1960s based on vacuum forming. References, Robinson Industries J. L. Throne, Understanding Thermoforming, Hansel Gardner Publications, Incorporated, Cincinnati, Ohio, 1999, Vacuum Forming Finishing Methods www.toolcraft.co.uk. Retrieved November 20, 2014 Vacuum Forming Roller Cutting Process www.toolcraft.co.uk. Retrieved November 20, 2014 Vacuum Forming Press Cutting Process www.toolcraft.co.uk. Retrieved November 20, 2014 Further reading, D. E. Walsh, Do-It-Yourself Vacuum Forming for the Hobbyist, Workshop Publishing, Lake Orion, Michigan, 2002, Soroka, W. Fundamentals of Packaging Technology, IOPP, 2002, ISBN 1-930268-25-4, Yam, K.L., Encyclopedia of Packaging Technology, John Wiley & Sons, 2009, ISBN 978-0-470-08704-6.